Alright, students, in this video, I'll be going through the 2014 O-Level Paper 1, Question 9. So it's a question regarding equations and inequalities. Okay, so the question goes, the equation of a curve is y equals to ax squared plus 5x plus a minus 5. So where a is a constant. So in part 1, they say that in this case, for this part 1, a is equals to 2. So let's go ahead and replace all the a with 2. So the equation becomes 2x squared plus 5x. Okay, a is 2, so 2 minus 5, it will become minus 3. Alright, so the equation of the curve is like this. Okay, then they go on to say that find the set of values for x for which the curve lies completely above the line. Okay, so the line equation is over here, y equals to 9. Okay, so now the curve lies completely above the line y equals to 9. So this means that we can actually form an inequality over here. Because if the curve lies completely over the line, it means that whatever value of y for the curve, it will be greater than 9. Okay, in order for it to lie completely above the line, y equals to 9. Right, so from here we can form the inequality, and then we can go ahead and solve the inequality, and that will enable us to find the set of values of x. Okay, so this is the equation of the curve. It lies completely above the line y equals to 9, so it will be greater than 9. Okay, so all we need to do is solve this particular inequality. Okay, so we can solve this inequality quite easily by bringing the 9 over. So you get minus 12 greater than 0. And then we will go ahead and factorize this. Okay, so if you factorize this, you should be able to get 2x minus 3. And then over here, you get x plus 4. Alright, so you can expand back and check if you have done the factorization correctly or not. Okay, so always remember that when you want to solve a quadratic inequality, you cannot simply just write in the next step 2x minus 3 greater than 0, x plus 4 greater than 0, and then solve for x and y. Solve for both the x, okay? What you need to do is you need to do a rough sketch. Okay, so over here, okay, so this is a smiley face because the coefficient of x squared is positive. Okay, so we're going to mark out the two roots. So the two roots will be here as well as over here, which is 3 over 2. Alright, so now we want greater than 0, so we will shade the part that is above the horizontal line, above this x-axis. Alright, so we're going to shade these two parts, and then we will get our answer very simply by just stating the regions, the values of x for the regions that we have shaded. Right, so you can see that this first region is to the left of minus 4. So in other words, over here we have x less than minus 4. And then in the second region, we have shaded the parts which is to the right of 3 over 2. So it will be all x greater than 3 over 2. Right, so this would be the final answer. Okay, this will be the set of values of x. Okay, for which the curve will lie completely above the line. Right. Right, let's move on to part 2 of the question. Okay, so now they say that in the case where a equals to 4, show that the line y equals to x minus 2 is tangent to the curve. Okay, so now since they say that the value of a has changed, become a different value, let's replace the a with 4 now. So we have 4x squared, okay, plus 5x. Okay, then remember it's a minus 5, so now a is 4, so 4 minus 5. Okay, maybe I'll just write an extra step over here. So this is when a equals to 4, right? Okay, so the equation will become 4x squared plus 5x minus 1. So I'm going to call this equation 1. Alright, so now we need to show that this curve, is tangent to the line y equals to x minus 2, or rather the line y equals x minus 2 is a tangent to the curve. Okay, meaning that if I do a rough sketch of the thing, okay, then the line y equals x minus 2, okay, will touch the curve at just 1 point. Okay, so this is y equals to x minus 2. This is the curve. Right, so they want us to show that this is the case. that it will not cut at 2 points or it will not meet at all. Okay, so equation 1 is the equation of the curve. Okay, then equation 2, okay, will be the equation of the line, right? So basically now we're going to equate 1 and 2, and then if it's tangent, when we try to solve it, we should only get one answer, right? So later on, we will just examine the discriminant in order to help us to come to that conclusion. Okay, so let's go ahead and equate 1 and 2. So equate 1 and 2. Okay, so you'll get 4x squared plus 5x minus 1 equals to x minus 2. Okay, then we bring everything to the left side. 4x plus 1 equals to 0. Okay, so remember, this is a show question. Okay, so for a show question, you cannot straight away state that b squared minus 4ac equals to 0. Okay, because although that is the case when the line is tangent to the curve. If it's a show question, you need to sub in the values into the discriminant b squared minus 4ac and then work it out and show that it's equals to 0. Then we can come to the conclusion. Okay, so in this particular equation over here, a is 4, b will also be 4, and then c will be 1. Okay, so let's go ahead and calculate the discriminant. So b squared minus 4ac. Okay, we're going to sub in all the values. Okay, so you can see we will have 16 minus 16 equals to 0. Then we can come to the conclusion already. Okay, so we can say that since, okay, let me write the conclusion over here. Okay, since b squared minus 4ac is equals to 0, y equals to x minus 2 is tangent to the curve. Okay, when a equals to 4. Right, so if you show that, if you calculate out the b squared minus 4ac and it's not 0, that means it's not tangent. So if the b squared minus 4ac is maybe something positive, that means the line will cut the curve at 2 distinct points. Okay, then you have real and distinct roots. Okay, if the b squared minus 4ac you calculate is negative, that means the line will not cut the curve, right? So this is how you solve this particular question. Okay, let's go on to the last part of the question. Okay, find the other value of a for which the line y equals to x minus 2 is a tangent to the curve. Okay, so now they say that there's another value of a, okay, at which this particular same line is also tangent to the curve. Okay, so since now we need to find that particular value of a, right? That means we don't know what's the value of a. So we should leave the equation of the curve in the original form, which is this form. Okay, let's call this equation 1. Okay, then same thing, the equation of the line will be equation 2. Alright, so let's equate 1 and 2. Equate 1 and 2. Okay, so we have ax squared plus 5x plus a minus 5 equals to x minus 2. Okay, let's bring everything to the left side, similar to what we did previously. So minus 5, you bring the 2 plus 2, you will get minus 3, a minus 3, sorry. Okay, so the a is still there, okay, plus a minus 3, so equals to 0. Okay, so basically when I try to solve this one now, okay, I should only get one answer, alright, one answer, because they say that find the other value of a for which the line is tangent to the curve. Okay, so for this question, they are not asking you to show. They are telling you that the line is tangent to the curve. Find the value of a for which that is the case. Okay, so for this question, we can go ahead and form the equation b squared minus 4ac is equals to 0. So if the line is tangent to the curve, then b squared minus 4ac equals to 0. Okay, so in this particular question, a is equal to a, okay, b is equal to 4, and then c is equal to a minus 3. Okay, so we're going to sub in all these values, and then we're going to solve for the a. Okay, so b squared minus 4 A and C equals to 0. Okay, so you get 16 minus A square. Okay, let's do an intermediate step, okay, to avoid making mistakes. All right. So over here, 16 minus 4A square plus 12A equals to 0. Okay, so basically what I'm going to do is I'm going to divide by -4. Okay, divide by -4 so that the coefficient of A square becomes positive. So if I divide by -4, it becomes A square. 12A divided by -4, you get -3A. 16 divided by -4, you get -4. Okay, then we will go ahead and factorize this. Okay, so always simplify a equation before you attempt to factorize it. Okay, so you can see once you simplify, it's much easier to factorize it already. So same thing, expand back and check if it's correct or wrong. Okay, so from here we will get two answers. Either A equals to -4. Okay, so either A minus 4 equals to 0 or A plus 1 is equal to 0. So A will be 4 or A will be equals to -1. Okay, so which is the answer that we want? So if you recall in part 2, okay, in part 2, we sub in the value of A equals to 4. So this is not the answer that we want. They want the other value. Okay, so in other words, this A equal to 4 is not applicable for this part. And the answer that we want is A equals to -1. Right? Okay, so this is the solution for this particular question.